So this is where we left off. We had found segment DJ. We still need to find the measurement of angle JAC. And as a reminder, I need phones put away, please. Phones need to be put away. We want the measurement of angle JAC. So JAC, I'm going to switch colors. There we go. That's this angle right here. Do we know how big that angle is? Do we know how big the angle next to it is? Well, that's a segment. That's 9.4. That's a segment. It doesn't have degree markings on it. I don't know how big this angle is. I don't know how big this angle is. But what did we call segment JC, segment JB, and segment JA? What are those all labeled as? Angle bisectors. What do bisectors do? Split things in half. In this case, because it's an angle bisector, it's cutting an angle in half. So up here, when I look at this angle, I see this little side is 28.5. So if that little side there is 28.5, how big is this angle right next to it? 28.5. So that means this whole angle up here is how big? If this one's 28.5 and this one's 28.5, how big's the whole thing? 57 degrees. I know over here that this little angle is 33.9 degrees. If that's 33.9, how big is the little one right next to it? 33.9. So how big is that whole angle right there? $67.8. All right, I'm going to re-sketch this triangle down here. Oops. Kind of like this. So C is here, B is here, A is here. We said this one down here is 67.8. And this one over here is 57. So what would I need to do to find this angle right here? Yep. We're going to add 67.8 and 57. And then do what? X, or I could call it angle BAC. But yeah, you could call it X plus the measurement of angle BAC. And what would that be equal to? 180. Three angles of a triangle add up to 180. So then we combine our two like terms here. That would give me, I think that's 124.8. Can somebody please double check my math on that? I just added it in my head and I'm not good with adding decimals. What is 67.8 plus 57? Okay, so I did it right. Awesome. So now I'm going to minus 124.8 from both sides. And that gives me the measurement for angle BAC is what? 55.2 degrees. So this angle right here is 55.2 degrees. That means this angle right here is 55.2 degrees. But I'm not interested in that whole angle. How much of the angle do I want? What'd you say? Both? What do you mean by both? What was the angle that was asked for again? What was the angle that was asked for? JAC. JAC, thank you. JAC is this angle right here. I know that these two put together gives me 55.2, but I don't want those two put together. I want just this one. So what can I do? Divide it by 2. Remember, this is an angle bisector. It's cutting my angle in half. So we're going to take 55.2 and cut it in half. The measurement of angle JAC is half the measurement of angle BAC. So the measurement of angle JAC is half of 55.2 degrees. What is half of 55.2? 27.6. So angle JAC is 27.6 degrees. All right. We are going to flip the page and look at one more example where we talk about angle bisectors in in-center. That'll wrap up everything that you need in order to do the homework that's due tomorrow. We are going to push forward into the notes into what is going to be covered on the next homework that you guys will receive tomorrow but won't be due until after break. All right? So let's flip over to page 8, problem 8. Page 8, problem 8 says J is the incenter of triangle ABC. So I'm going to draw a little arrow here. We are going to label point J as the incenter. The incenter is where 3 special segments come together and touch. What is the name of those 3 segments? What types of segments come together to form the incenter? Angle bisectors. So give me the name of one of the angle bisectors in the picture. BF. Technically BJ. I know it looks like BF. That's just the way the drawing is. So we go from the corner to the incenter. That's an angle bisector. So that means this angle is the same size as what? This is an angle bisector. This angle up here is the same size as, yes, JBE, the one right below it. This angle right here would also be 45 degrees. Give me another angle bisector in the picture. CJ, right here. This would also be an angle bisector. So that means this angle right here, that's 22.5, is the same as what other angle? JCF, this angle right here. So this one would also be 22.5 degrees. What is another angle bisector in the picture? AJ. This is an angle bisector. Do we know how big either of these 2 angles are? No. But what do I know about those 2 little angles? What was true about these 2? They're congruent. What's true about these 2? They're congruent. So what's true about these 2? They are congruent. I don't know how big they are, but I know they are the same size. So I can go ahead and mark them as congruent. So if those are all angle bisectors, and J is my incenter, what is true about these other 3 segments here? They are all congruent. So how big is each one? 12. This one's 12. This one's 12. This one was already marked as 12. All right, let's see if we can answer the questions over here. They want the length of DJ. DJ is this segment right here. Well, we just said that's how big? 12. Because it is congruent to JF, which is labeled as 12. And it's also congruent to JE. All right, now we want the measurement of angle JBE. JBE. So this angle right here. How big did we say that was? 45. All right. Then we want angle FAJ. FAJ is this little angle right here. Do we know how big that one is? No, that was one of the ones that we didn't know. But I know how big these two are. I know how big these two are. What do I get if I put these two together? What do I get if I put 45 and 45 together? 90. What do I get over here if I put 22.5 and 22.5 together? 45. So I'm going to sketch this triangle over here. So B, C, and A. We said this is 90. Even though it doesn't look like a right angle in the picture, that doesn't matter. This one is 45. So what do I do to figure out this one? What'd you say? What do I need to set equal to 180? All the angles. So we're going to take the 90 plus the 45 plus the measurement of angle BAC. We'll set that equal to 180. What do I get when I combine 90 and 45 together? 135. So I have 135 plus the measure of angle BAC is equal to 180. And then I'm going to subtract 135 from both sides. What is 180 minus 135? 45. So this angle right here is 45 degrees. But that's the whole thing. That's these two pieces put together. So how do I get just this little one? Yes, we're going to divide it by 2. We're going to say the measurement of angle FAJ is equal to half the measurement of angle BAC. So the measurement of angle FAJ is half of 45 degrees. What is half of 45? 22.5. So angle FAJ is 22.5 degrees. All right, one last question here. We want the measurement of angle JCF. JCF. This angle right here. Do we know how big that one is? How big is it? Perfect. No work to do on that one. 22.5. All right, very nicely done. Like I said, that's the last example that you need to finish up the homework. The homework is over perpendicular bisectors and circumcenter. That's the front side. Angle bisectors and incenter. That's most of the back side, except for the very top problem. All right. So now we're going to move on into the new notes that'll go with the new homework. We're going to talk about some new types of segments and points of concurrency. So first thing we're going to do is define an altitude. An altitude is a segment that goes from a vertex to the opposite side. And is perpendicular to that side. Goes from a vertex to the opposite side and is perpendicular to that side. It does not have to go through the midpoint. All right. Does anybody not have a straight edge on their desk? Does anybody not have a straight edge? Because we're going to draw in the altitude on this picture. You need one? Anybody else need a straight edge? All right, so we're going to draw in our altitude. I'm going to start at this top corner, and we're going to go straight down to the bottom. And where it hits the bottom, it makes a right angle. This is my altitude. This point right here is not the midpoint. A median is a segment that goes from a vertex to the midpoint of the opposite side. It does not have to be perpendicular to the opposite side. So over on my little triangle, we're going to draw in a median, which means the first thing I need to do is identify the midpoint. Because it's the midpoint, these two segments would be congruent. And then going from the opposite corner to that midpoint is my median. Thank you, Landon. We are on page 8 in your notes. Page 8 in your notes. All right, give you guys just a moment to continue writing this down into your notes. All right. Let's look at an example now. Down at the bottom of the page. Using the picture to the right, it says that the length of segment BE is equal to the length of segment EC. If I have segments that have equal lengths, what does that mean about them? They're congruent. So segment BE is congruent to segment EC. So let's go over to the picture and mark those as congruent. So BE, this segment right here, is congruent to EC right here. If those segments are congruent, what is the special name for point E? Midpoint. That's the midpoint. Then they also tell me that the measurement of angle ADB is 90 degrees. ADB would be this angle right here. All right, so first question that they ask me is which segment is the median? We just wrote down, just a little bit above on the same page, what a median does. Median goes from where to where? Yes, vertex to the midpoint. Which segment in the picture goes from the vertex to the midpoint? Which segment goes from vertex to midpoint? AE. AE would be my median. So we're going to write that down on the line. AE. And then we want the altitude. We just wrote down that altitude goes from where and does what? Yes, vertex to opposite side. And what happens when it hits the opposite side? Yes, perpendicular, which means makes a right angle. Perpendicular to the opposite side. Which segment up here goes from the vertex and makes a right angle with the opposite side? AD. So AD is my altitude. Is AD the perpendicular bisector? Is AD the perpendicular bisector? No. There's two things going on. Is AD perpendicular? Yes, AD is perpendicular. We have that right angle marking on there. What do bisectors do? Cut things in half. Does D cut this side in half? So it's perpendicular, but it's not a bisector. So I would say no, because what would D have to be if this was the perpendicular bisector? Yep, we need to be congruent on either side, and we call that the what? Midpoint. D is not the midpoint. To be a perpendicular bisector, it has to hit the midpoint. So no, because D is not the midpoint. Is AE the perpendicular bisector? No. Why not? It's not perpendicular. So we don't get the perpendicular part, but we do get the bisector part. It's got to do both jobs to be a perpendicular bisector. So I would say no, because AE is not perpendicular to BC. All right, last question. It says, if the measure of angle ADE is equal to 7W minus 22, find the value of W. Well, let's go find angle ADE. ADE. DE. What kind of an angle is that? That's a right angle. How big are right angles? 90 degrees. So angle ADE is a 90-degree angle. So I have 90 equals 7W minus 22. And now we're going to solve this for W. So I'm going to add 22 to both sides. What is 90 plus 22? 112 equals 7W. And then we divide both sides by 7. What is 112 divided by 7? 16. 16 equals W. Absolutely fantastic. All right. Let's go look at number 4, next page. Let's flip the page. So that's medians and altitudes. We said we were also going to talk about centroids and orthocenters. A centroid is the point of intersection of the 3 medians of a triangle. The point of intersection of the 3 medians of a triangle. This is also the center of mass. I'll see if I can find my triangle for tomorrow, but I have a triangle that is cut out of cardboard, and I've drawn in the 3 medians. Where those 3 medians cross, I can balance that whole triangle on the tip of this pen. If I put the tip of the pen right on the point where the 3 medians cross, the entire triangle will balance. It is the center of mass, my balance point. The orthocenter is the point of intersection of the 3 altitudes of a triangle. The point of intersection of the 3 altitudes of a triangle. All right. Let's look now down at number 6. We are going to mark this triangle up, and we are going to use it to identify the centroid of the triangle. So first thing I want to do is we're going to find the midpoints of the sides, and we're going to label them D, E, and F. So here on side AB, do your best to locate the midpoint. We're going to call that D. That means that AD and BD would be congruent. Over here on side BC, we're going to do our best to locate the midpoint, and we're going to call that F. Because that's the midpoint, that means that BF and CF would be congruent. And then down here on side AC, we're going to find the midpoint and label it E. So AE and EC would be congruent. Once you have done your best to identify the midpoints of those sides, we are going to draw in the 3 medians. So a median goes from a midpoint to the opposite corner, like this. Use your straight edge to draw that in. From a midpoint to the opposite corner. Midpoint to opposite corner. And what you should see is that if you've done a good job of identifying where the midpoint is, These three lines should all be intersecting. If they come close because you didn't find the exact midpoint, that's okay. We're going to put a dot where they cross, so you might just need to make your dot a little bit bigger. We're going to label that as point G. And I'm going to draw an arrow to it and call it the centroid. The location of that centroid splits my medians into two parts. This part and this part. Or I could look at a different median, this part and this part. Are those two pieces congruent? No. But there still are some special properties with my centroid. So notice on each of these that we have a short segment and a long segment. The short segment, so the segment that goes from the centroid to the midpoint, we are going to label as X. The long segment, which is the piece that goes from the centroid to the vertex, is twice as big. So we're going to label that as 2x. So looking over at my picture, if I'm looking at this whole median right here, this would be my short segment, so I'm going to label that as X. And this would be my long segment, so I'm going to label that as 2x. Same thing on this one. This would be X, and this would be my long segment, so that would be 2x. On my purple median, here's my short segment, so that would be X. Here's the long segment, so that would be 2x. Question. If the short segment is X and the long segment is 2x, then when I look at one whole median and I put those two parts together, that would give me how much? If I take 2x and 3x and I put them together, sorry, 2x and x, I get 3x. So the whole median is 3x. Short segment we're going to call x. Long segment we're going to call 2x. So the whole median, when I put those two parts together, is 3x. We're going to do problem number 7 and call it a day. We're going to practice this. We'll continue practicing this after break. You guys will get the homework that goes over this tomorrow, so you can start on it before break if you want to, but we'll do more practice after break, and then it won't be due until the Tuesday after break. All right, so let's look at number 7 here. It says that G is the centroid. So let's put a little dot at G. Draw an arrow to it, label it as the centroid. If G is the centroid, what's the special name for point F? Midpoint. So what two segments would have to be congruent then, if F is a midpoint? BF and CF, yes. What's another midpoint in the picture? What's another midpoint in the picture? G, or sorry, you said G? D, I'm sorry. D is the midpoint. D is a midpoint. If D is a midpoint, what two segments would have to be congruent? AD and DC. Give me another midpoint. E. E is a midpoint. So what segments would have to be congruent? AE and BE. All right. This little segment right here from the centroid to midpoint D, would that be labeled as X, 2X, or 3X? This little segment right here, am I going to call this X, 2X, or 3X? Think about the picture we just did a moment ago. X, that's the short one. So the other side of the same median would be what? 2X. What about this segment here? Would that be an X, a 2X, or a 3X? That's an X. So what about this segment? 2X. Is this one X, 2X, or 3X? 2X, yes. So what would this one be? X, perfect. So we've got it all labeled up. Now we're going to go look at the questions that they're asking us. It says segment AF has a length of 48. Well, segment AF is this whole median. Is a whole median X, 2X, or 3X? 3X. So that means 3X equals 48. What do I do to figure out X? Divide by 3. What's 48 divided by 3? 16. So X would be 16. They want me to find the length of AG. AG is this. Is that X, 2X, or 3X? 2X. So if this is 2X and X is 16, what is 2 times 16? 32, yes. What about GF right here? Is that X, 2X, or 3X? X. So how big is GF then? 16. Nicely done. All right. Part B, which has absolutely nothing to do with Part A. So the numbers that we had in Part A don't carry over into any of these other parts. It says BG equals 30. BG is this segment right here. Is that X, 2X, or 3X? 2X. So that means that this is 2X equals 30. Well, if 2X is 30, how much is X? 15, yes. So if X is 15, how big is GD down here? X, and so that would be how much? 15. BD, this right here, X, 2X, or 3X? 3X. And we said that X was 15, so how big is BD? 45. All right. It says EG is 7. EG is this right here. Is that X, 2X, or 3X? X. So this is X equals 7. GC would be this right here. Is that X, 2X, or 3X? 2X. And we said X was 7, so 2 times 7 gives me what? So GC is 14. EC, X, 2X, or 3X? 3X. And we said that X was 7. So how big is EC? 21. Perfect. We've got just part D to go, and then we are done for today. It says that AD is 4X minus 2. That's this right here. 4X minus 2. And then it says that AC is 3X plus 13. That's this right here. 3X plus 13. D is the midpoint, right? What do midpoints do to segments? Split it in half. So how many segments this big do I need to make this? I need 2 of them. So 2 times segment AD gives me segment AC. So 2 times 4x minus 2 equals 3x plus 13. I'm going to distribute the 2. What is 2 times 4x? 8x. And 2 times negative 2? Negative 4. So 8x minus 4 equals 3x plus 13. We're going to get our x's to the same side, so I'm going to minus 3x from both sides. What is 8x minus 3x? 5x minus 4 equals 13. Then I'm going to add 4 to both sides. What's 13 plus 4? 17. So 5x equals 17. Then we divide both sides by 5. What is 17 divided by 5? 3.4. So x is 3.4. All right. As I mentioned earlier in the class, your homework number 2, the one about perpendicular bisectors and angle bisectors, circumcenter and incenter, is due tomorrow. Due tomorrow. You also have a skills check tomorrow. If you want to study ahead of time, that'd be pages 1 through 8. Just the top problem on page 8, 1 through 8. Stuff covered on homeworks 1 and 2. I don't know that I will have time to give you to study for that after we get done grading homework because we're going to have a shortened schedule due to the volleyball game. After break, we will finish up these notes about medians and centroids, and you will get the new homework that's due after break tomorrow when you turn in homework number 2.